Uh, Dear students, welcome back. This is lecture 12. I've already sent you all the material plus video of lecture 11 before starting the correlation diagram. Okay, of D2 we will discuss. As you know, I have very in good detail discussed with you the diagram for D1 case. D1 is simple. Okay, it's a one electron. So there was a term diagram for that. If you see the lecture 11, and there is only one transition, and there will come only one band. Okay, now D2 is different. There are two electrons, they must interact with each other. Inter-electronic repulsion. So this is no longer a simple case. But as you will see, it is not difficult as well. The key thing is correlation diagram, what it is, term diagram, what it is, and what is the benefit of this correlation diagram. You will automatically get to know about it when we will be able to predict the spectra of D2 or D3, D4, and so on and so forth. We will be able to predict, and this is the spirit of this course, electronic spectra of coordination compound. Today, I will discuss with you D2 spectra correlation diagram of D2 and its spectra. So before I do that, I think will be good if you just revive what is this term diagram. And now the second word, correlation, is coming. You are familiar with the configuration, D1 configuration, D2, D3. Now D2 gives S, P, D, F, and G. There are triplet terms and there are singlet terms. Okay, triplet are F3, P3, G1. You already know about it. You can drive it. So in a weak field, okay, these SPDF, okay, these terms, they also split up. Now, in this diagram, I'm showing you term diagram of D1. Okay, the D1 case, ground state D2, you can derive it conveniently yourself. So when this is free ion, put it in octahedral, this will give this and this. Now please note, I put 2 here. This is spin degeneracy because it's one electron. So 1 plus 1 is equal to 2. There will be this transition only T2G to EG. So there should be only one absorption band. Now this is different. Okay, there are triplet states and then there are singlet states also. This singlet, this singlet. It will become very complicated diagram. But here I'm just showing 2 triplet states and F, a triplet F, free ion term. When this is put in the octahedral field, then what happens? Well, this splits up into this, this, and this. This is, as you know, orbital degeneracy F7. This is triplet, orbital degeneracy 3. This is also 3. This is 1. 3 plus 3 plus 1. It is 7. Similarly, this is P, triplet P. It does not split. Okay, it stays the same. This is T1G. It becomes T1G, group theoretical term. Okay, so it comes from P. I have put P here. So this is term diagram D2. Now we come to the correlation diagram of D2. In octahedral strong field, it gives these, okay, ground state, excited state 1, excited state 2, okay, only two states here is the, on the next page, this is the ground state T2G2. This is excited 1, T2G1, EG1, and this is EG2 excited state. Now, see what happens. These, okay, when interelectronic repulsions are considered, then these configurations split up into a number of terms. Okay, we can obtain those by direct. ABP lever, you already know, I gave it in your examination also, the product of T2G and this, because it is already covered in lecture 9. Okay, in octahedral field, D2 gives these states. You have already driven these, you know them well, okay? And it's a D2 case. So how many microstates? 10 divided by 9 divided by 2 equal to 45 microstates. Similarly, these states which they come, okay, they also give you 45 substates or microstates. This is 7 multiplied by 3. Okay, this is P, triplet P, okay, so 3 multiplied by P is 3. This is wrong, written wrong here. 3 multiplied by 3. Okay, and G, okay, 9 multiplied by 1, okay, 5 multiplied, and total is 40. 45. Okay, now let's come. In weak octahedral, the free ion terms give D2, give rise to the following energy states. These are the energy states, weak field. Okay, in this table, D2, weak octahedral field, okay, what I'm doing? Okay, I'm showing how many states it contains, and then when it is split, okay, it splits into this, this, and this. Okay, and the number of states this contains is 3 multiplied by 1. 3, this is triplet. Okay, 3 multiplied by 3. This is 3, and then this is triplet. 3 total again is 21. 21 and 21. And similarly, P triplet, and P is 3 orbital degeneracy, 3 multiplied 9, and this is also 3 multiplied 9. If you calculate, this whole thing will come. This table is very clear. I have put it here, 45 here, and 45 here. In strong field, this doesn't happen. These terms, okay, what we are getting is, we are getting ground state, T2, excited state, this one, and EGT, next excited state. Number of microstates contained in each of the configuration that can easily be calculated. See table 4 on page 6. Okay. This is page 4. I think I would like to just show you that it is here. T2G, how many microstates? 15. You know how to calculate that. And when you multiply these two, okay, it is given in the table below and also given in ABP lever book, page 41. When you multiply, it gives this, 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 and this. Okay, spin multiplied by orbital degeneracy. Number of microstates, spin degeneracy, microstates. Oh, you know already all this stuff. Okay, so this is equal to 15. When you do this, now this is, please see this, T2G1. It's just like P1, 3. Maximum occupation is 6. Contains 1 electron, say. And this E contains maximum 4. Okay, there are 2 orbitals. 4 divided by 1, 24. And on right hand side also, when it splits, it gives this, and 24. And similarly, Eg2, well, Eg4 divided by 1 multiplied by 3 divided by 2, 6. This is 2, okay, 2 electrons. Okay, 1 and okay. So this again, 6 and 6. So whatever is on the left hand side, after splitting, what you get should be equal to the same. Once now we know the states from the weak field, okay, see back page 1 or 2 back page, and these are the states which come from the strong field. What you do? You put them weak field on the left side and the strong field on the right side. And then you will be able to generate a diagram like this. Okay, this is weak field things, okay, written here. And these are T2G, and it gives this. T2G1, EG1, it gives this. And then EG2 gives this. Okay, so what we do then? Then we connect them according